Okay, next is operations on matrices. Okay, in this section, I will explain to you three cases about operations on matrices. There are addition and subtraction of matrices, multiplication of a matrix by a scalar, and also multiplication of two matrices. And also in this section, I will show you the examples and concept of operations on matrices. Okay, now let's start with case number 1, addition and subtraction of matrices. Okay, in this case, you are given two matrices. Okay, let's say matrix A and matrix B. And these two matrices can be added or subtracted if and only if they are of the same order. Okay, now look at these examples. Okay, these are two matrices of order 1 by 2 and 2 by 1 respectively. As you can see here, these two matrices cannot be added because they are not of the same order. While in example 2, as you can see here, these two matrices are of order 2 by 2. And then these matrices can be added because they have same order, and we can see the result of this process is also a matrix of same order, which is 2 by 2. And to carry out the process of addition and subtraction, we can add or we can subtract the corresponding elements of these two matrices. Okay, for instance, look at example 8. You are given two matrices, matrix A and B, okay, of order 3 by 3. And then we know that these two matrices can be added or subtracted because they are of the same order. And the outcome of addition and subtraction process of these two matrices must be a matrix of order 3 by 3 as well. Okay, let's say C with element C11, C12, C13 until C33. Okay, as I mentioned earlier, to solve addition and subtraction of two matrices, we can add or we can subtract the corresponding element of those matrices. Okay, now to solve A plus B, I will start at row 1, column 1 of matrix A, where the element here is 2. Okay, and then this element can be added to the element of matrix B at the same position, which is 1. And then the outcome of this addition must be an element at the same position, which is row 1, column 1. Okay, and that matrix C, the outcome of this addition, and then we can have the element of matrix C at row 1, column 1. Okay, as you can see here, we have 2 plus 1, and then the outcome is 3. And then we can repeat the same process at the next element, okay, at row 1, column 2 of matrix A, which is a -1, can be added to the element at the same position of matrix B, which is 0. And then the outcome of this addition is an element of row 1, column 2 as well. Then as you can see here, -1 plus 0, then the outcome here is -1. And then repeat the same process on the next element. Okay, this one, this one, this one, and this one, until the addition of each element is complete. Okay, next, the same process will be applied to subtraction of two matrices. Okay, as you can see here, and the element at row 1, column 1 of matrix A, which is 2, minus the element of matrix B at the same position, which is 1, and then the outcome must be an element of matrix C at the same position, row 1, column 1. And as you can see here, 2 minus 1, okay, the outcome of this subtraction is 1. And then we apply the same process to the next element, okay, until the subtraction of all corresponding elements of these two matrices are complete. Okay, case number 2, multiplication of a matrix by a scalar. Now let's say you are given a matrix A and then a scalar K. Then multiplication of a matrix A and scalar K can be written as KA. So the product of K and matrix A here is obtained by multiplying each element of matrix A by K. Now look at example 9. You are given matrix A and then find 2 times A, where 2 here is a scalar and then A here is the given matrix. Then the product of 2 and matrix A here is obtained by multiplying each element of matrix A by 2. And we can see the process here is 2 times 1, where 2 here is a scalar, then 1 here is the element of row 1 column 1, and then we apply the same process to the next element, element of row 1 column 2, row 2 column 1 and row 2 column 2. Then we can see the process here, and also the final product is a matrix of 2 by 2 as well, with element 2, 4, 6, 8. Next is case number 3, multiplication of matrices, and in this case we consider multiplication of 2 matrices only. And before we continue the process, the first step is we need to check the compatibility of 2 matrices that involved in this operation, and I will show you later on how to check the compatibility of 2 matrices. And if those 2 matrices are suitable for operation, then we can proceed the multiplication process, and the product of those 2 matrices is a matrix of order m by n. And then if those 2 matrices are not suitable for operation, then the multiplication is not valid and we can stop the operation. Let's say you are given 2 matrices, matrix A of order m by p, and then matrix B of order p by n, and then we can say that these 2 matrices are compatible for multiplication if the number of columns of matrix A equals the number of rows of matrix B. And we can see that the resulting matrix after this operation is a matrix of order m by n. Now look at the example. If matrix A of order 1 by 4 and matrix B of order 4 by 4, then we can say that these 2 matrices can be multiplied and matched for operation, because the number of columns of matrix A equals the number of rows of matrix B. And then the resulting matrix after this operation is a matrix of order 1 by 4. Once the compatibility of 2 matrices is checked, then we can apply principle row into column and dot product to carry out the multiplication process. And now look at this example. Given matrix A of order 2 by 2 and matrix B of order 2 by 1, and then these 2 matrices can be multiplied because the number of columns of matrix A equals the number of rows of matrix B, and then the resulting matrix here is a matrix of order 2 by 1, as you can see here. And then the element of this matrix is element at row 1 column 1 and element at row 2 column 1, and this element is obtained by multiplying the first row of matrix A with the first column of matrix B. And then as you can see here, the first row of matrix A multiplied with the first column of matrix B will give you the element at row 1 column 1. And to solve this multiplication, we need to apply dot product, where we multiply the matching members, then sum up the products. As you can see here, 1 times 5 and then 2 times 6, and then sum up the products, then we will have the answer here is 17. And the same goes to get the element at row 2 column 1 here. Then we need to apply multiplication of row 2 and column 1 of matrix B. So you can see here, row 2 of matrix A and then column 1 of matrix B, and then the process here is 3 times 5 plus 4 times 6, and then the result here is 39. Okay, now look at example 10. You are given matrix A of order 2 by 3 and matrix B of order 3 by 2. Then these two matrices can be multiplied because the number of columns of matrix A equals the number of rows of matrix B. Then it will give you a matrix of order 2 by 2 with element denoted by C11, C12, C21, C22. And C11 here, okay, is obtained by multiplying the first row of matrix A with the first column of matrix B. Then we will have the element at row 1 column 1. Okay, and then we multiply the matching members and then sum up all the products. And as you can see here, 1 times 1, okay, plus 0 times 5, which is 0, and then 2 times 4, which is 8. Then sum up all, then we get the answer here is 9. And same goes to get the element at row 1 column 2. Then we multiply the element of row 1 of matrix A, okay, with the element of column 2 of matrix B. Then multiply the matching members and then sum up all the products. And as you can see here, 1 times negative 3 is negative 3, plus 0 times 1 is 0, and then 2 times 2 is 4. Then sum up all, we will have the result here is 1. And next, to get element at row 2 column 1, then we multiply row number 2 of matrix A with column number 1 of matrix B. And as you can see here, we can have 3 times 1 is 3, plus negative 1 times 5 is negative 5, plus 4 times 4 is 16. Then the result here is 14. And the last one here, okay, the element at row 2 column number 2. Okay, we multiply row number 2 of matrix A with column number 2 of matrix B. Then we will have 3 times negative 3 is negative 9, plus negative 1 times 1 is negative 1, plus 4 times 2 is 8. Then the result here is negative 2.